everyone, I am Anjan and welcome to the second video tutorial of the Verilog course series. In this video, you will be getting to know how the half adder works and how to design a Verilog code for half adder in the behavioral modeling style. For a better understanding, I split the video into three parts, that is pre-coding part, coding part and the post-coding part. Now let's move on to the pre-coding part. In the pre-coding part, you will be seeing the circuit diagram and the truth table. And now what is a half adder actually? Half adder is a circuit which is capable of taking two 1-bit binary numbers as inputs and giving sum and carry as outputs for the two 1-bit binary numbers. Now coming to the truth table, you can find the nature of the truth table that we will be having three cases, that is sum and carry are 0, 0 is as the first case, and sum and carry as 1, 0 that is the second case, and sum and carry as the 0, 1 that is the third case. I will be using these three cases in developing my Verilog code. Now let's move to the coding part. In the coding part, I declared half adder as my module name, and I will be taking x and y as the inputs in place of my a and b. I replace it just a with x and b with the y, and I will be replacing sum and carry with s and c. Here is s and c. And the most interesting part is I declared s and c as register, which means register can store any data. Here register s and c are storing the output data of the inputs a, x and y. And coming to the always block, I declared x and y as the sensitivity list. I declared x and y as the sensitivity list because if one of the variable, that is x or y, if or both can change, the whole output will change. It will affect the output. Now coming into the always block, you can find my three cases, that is if x equal to 0 and y equal to 0, or if x equal to y 1 and y equal to 1, or else this is the third case. For these three cases we will be having the outputs as I mentioned in the truth table, that is x equal to 0, and y equal to 0 if both are true, then sum and carry is equal to 0. If x equal to 1 and y equal to 1 if both are true, then sum equal to 0 and carry equal to 1, or else the other case in which sum and carry equal to 1 and 0. You can write this by using the truth table here. Now let's move to the post coding part, that is into the Vivado software tool. Here is the Vivado software tool. I just copy paste the same code into this tool. Here it is, module, half adder and always block, and coming to the end module up to that I copy paste this whole thing. Now for the time sake, I previously just simulated it and kept for you. Here is the simulation for you, and you can see in the previously, before giving any inputs x and y, that is or a comma b, you can say are z, that is impedance, which means they are not having any value, so that the output will be unpredictable. So now I am giving the inputs as 0, 0. That means a and b are as 0, 0, and the output will be 0, 0. I will be running it for 10 microseconds. Here I got the sum and carry as 0, 0. Now I will be giving 0, 1. Yeah, I got the sum as 1 and carry as 0. Now I will be changing this as 1 to 1, 0, that is a, b as 1, 0, so that the output will remain same. Here you can see that the output remains same. Now if I change the y to 1, that is the last condition, the answer we will get is sum is 0 and carry is 1. Here I got it. If I zoom fit the whole graph, you will be seeing a neat graph which is getting here. For the first 1 microsecond, it is we didn't given any inputs. For the next 10 microseconds, we are given the 0, 0 as the inputs, so that we can get the sum and carry as 0, 0. And the next 10 microseconds, that is 11 microseconds to 21 microseconds, we will be getting the output as, that is 0, 1, where the inputs are 1, 1. Where the inputs are 0, 1 and the output is 1, 0. And here the graph will flow. Now, coming to schematic, you will be getting the schematic. Here is the schematic. You can find that this is different from the schematic which is you saw in the pre-coding part. This circuit, you will find an XOR gate and AND gate, simple two cells here, but you will be seeing nearly 7 cells, that is 2:1 muxes, 3 2:1 muxes, 2 AND gates and 2 equators. That is total of 7 cells. You can see the circuit diagram is different from the previous circuit diagram you have saw, but the functionality is same with compared to the previous one, because we use the behavioral modeling. If you want the same circuit diagram which you have seen in the pre-coding part, you can pause the video and try it with data flow modeling or gate flow modeling. You can get it further. If you are not getting it, I will be showing it. Here is the gate level modeling with half adder. I use XOR as sum, XOR and AND gate, where sum is the output for XOR gate and C is the output for AND gate, and here I got the outputs. You will be getting the same circuit which you saw in the pre-coding part. No, if you are not need to worry, I will be giving the same code in the description box. Now if you like the video, you can do like, share and subscribe the Start Scratch channel, and keep learning.